Hello, students. We are going to test out these amazing tools. So what we've got today is a little show of how do I use these, and I want to make sure we understand how to use them and what the purpose is. So I've got a document camera here. We're going to give it a shot. I've got here, this is the Stadler. Stadler's the name of the company. This is the 550 model. And I'm going to go ahead and open it up just to kind of show what it is. So what we have here is the main tool. This is known as a compass. Okay, not a protractor. Protractor measures angles. This does not measure them. It has a few additional features. So one of the features here is a small little container. And in this container, if you can kind of hear it rattling, hold it up to my microphone. What's inside that is another piece of lead. So you'll notice on this device, there is one pokey sharp piece, which is located right here, and then one lead, and that's where the drawing is done. So the pokey sharp piece goes into the pencil, and then the lead piece kind of makes the marks. So it did come with one additional piece of lead, and you can also get additional leads or a lead sharpener if you really enjoy that. And while they're called leads, I think they're pretty much all made out of graphite now because lead is toxic. Okay, other features. It has an additional length here so that if you want, you notice this is another pokey piece. It can go on the pokey piece side so that you can make larger circles. Okay. So the device itself will only make circles and lengths up to a certain size. This allows you to go a little bit bigger. And it also has on the other side for the lead, it has a piece that can go and be inserted here and allow for a clicker pencil or some other type of pencil to be able to fit in here. And the reason why you may want that is that that creates a crisper point. Let's see if I can hold those up. You see, the clicker pencil is pretty tiny compared to the thickness of the lead. But again, that's the options that are available. If you just got yourself a kind of the standard feature, you'll be just fine for most of the things we do in this class. You do have to be a little bit careful as you use the lead more and more. It will get dull, and a dull piece of lead, as you can kind of see from the tip here, it's a little bit flat, and it's just going to make a bigger mark. Okay, so everything stays in the case, close the case, everything's good. Now, my particular case, the newer model does come with a ruler on one side, but just so we're all clear, what we're doing is we're going to be using a compass and a straight edge. It doesn't have to have any ruler marks, and as a matter of fact, very rarely will we use it for ruler marks. Okay, so let's open this back up. Again, on the side just has a little press button. We just press lightly and it comes right out. So let's talk about why we have these tools. These are known as the tools of geometry. And so if you take a look, the compass, again, with its pokey part and lead part, has a spiral piece in the middle here. And if you twist this, you'll notice that it brings the two tips together. If I roll it in the opposite direction, it widens them out. So what's interesting is this device, even though it seems a little strange, this device is how we measure distances. Okay. So if I needed something that was 1.5 inches long, I would come over here and line this up until the pokey part was on one part and the other lead was on the 1/2 inch. And now I know this length is 1.5 inches. If I needed something that was 2 inches long, I'd have to widen this out to gain something that is 2 inches long. And there it is. So this is how we measure distance, is with this device. This device makes circles. Okay, I'm going to set it aside momentarily because a couple of the rules that we have when we're dealing with geometry. Yes, we still have points. So you can always have a point. A point, if you think about it, you could kind of think about drawing a point anywhere, but wherever you have a point, you can create a line or a line segment using the straight edge, right? So as you connect them, I now have formed a line segment. Now you might be tempted, and we'll see in this class, that if somebody says, hey, find the midpoint of that segment, find the thing that cuts that segment in half, you'll be tempted to use the ruler and see about how long is it and where's halfway according to that. But we're going to show you techniques for using this compass to create midpoints. Okay, so again, that's what we're going to be doing in this particular class. All right. So what else do we have? If we have a segment, that's perfectly fine. If we know an additional point, we know exactly where it is, and we make another dot, that's fine too. But then we could create another line or line segment, and that would, of course, create an angle. Okay. So now I've got a nice angle drawn here. I could connect this last segment between the 2 points. But in order to create additional points, I need something else. So let's just say that I had a ray coming off in this direction, and that ray may go on forever. Then I have where 2 segments have intersected, that creates a new point. Okay. Now, you put the pokey part of the compass, you have to put it on a point. You cannot just stick it out here in the middle because there is no point listed as to kind of where that center would be. All right. So let's see why we would use this compass and what we can use it for. So what I'm going to do is I'm going to take this length, I'm going to label point A and point B, so that's clear. And then I'm going to put the pokey part in A, and I'm going to adjust the length so that it touches B. Now I'm going to roll it in here just so we get close. If you have the type of compass that allows you to pull apart or push together, that can create something of an easier way to do it. You want to be gentle with it because if you pull too hard, it'll strip a little bit of the gears and it'll make it hard to hold together. So we want it to be firm when we press against it a little bit. If we press too hard, then it's okay. Some of these will actually pull together, and that's built into this piece. So again, if you do use it to pull, I would recommend that you actually use the wheel for most of your adjustments because that's going to save the compass itself. So right here, if I leave it here with the pokey part and I bring it, you can see that if I was to try to draw an angle, it doesn't go through B. So I need to widen out a little bit, okay, because I want it to go right through B. Okay, there it is. That goes right through B. What I have now in my compass is it is measuring the length of AB. So if I put my point on A and I swing another arc, and I want to demonstrate this, I'm pushing a little bit of pressure on the pokey part, and then I tip my compass instead of straight up and down. If you try straight up and down, it's going to be very hard to make circles. So tip your compass towards you and then let the lead touch, keeping pressure on the pokey part, and that allows a turn. So see what I've done is I took the length from AB. I've now turned from point A. So what I have is I know this length is the same. That creates a point, and that I could label as point C. And off to the side, what I now know is I know that AB, that segment, is congruent to AC as a segment because I built them with the same compass length. I'm marking them with 2 little tick marks. I could have used 1 tick mark, but I did 2 to illustrate those 2 lengths are now the same. Okay. So the compass as a tool allows me to take lengths from any point. I can put the pokey part into a point, and then again, don't go straight up and down, tip. And as you turn, you will create, and you do have to keep that angle kind of going the whole way. Keep the push, the pressure on the pokey part. That's what's going to keep it locked in place. And then keep that tip, the tipped status, and then kind of roll your wrist. It does take a little bit of practice, but as you can see, I'm kind of keeping pressure with my finger on the pokey part while letting the compass make a turn. And you can see you make beautiful circles that way. And what's the purpose of a circle? The circle is saying any distance from a point to that center, any distance is exactly the same because that creates a radius. So that's what we have. We have this length, we have that length. Any length on this circle is going to be exactly the same from the center to the outside edge. So I've created a circle right here centered at point C with radius of AC, whatever that length is. Okay. So if I wanted to create an isosceles triangle, now I can. I create another point on that circle. Excuse me. And then I'll use my straight edge to connect C to this new point, and I'll call this point D. And if I do create that length right here, guess what? That length is the same length as AC because they're on the same circle. And now if you construct A to D as another segment, I've got a triangle here that I can guarantee you is an isosceles triangle because these two sides are exactly the same. Could it be equilateral? Maybe if AD matched the same size as well. So this gives us opportunities to create shapes that we know exact sizes of. And that's kind of a cool feature of these tools. So let me build one more just to kind of demonstrate that. So I'm going to start with a line segment. Okay, so let's start with a point. I'll draw a line segment. Okay, there we go. So I want you to watch what I'm going to do next. So I'm going to label this as A, and this one is B. I'm going to take my compass, and I'm going to mark off. I'm going to bring this out until it touches B. So I know this is exactly the length of AB. There we go. Just adjust it. I always do a little turn to make sure it goes through. Now keep my compass pokey part in that spot and just turn upwards. There we go. Now take the pokey part and put it in point B. And if you look, it should go right through A. It does. And then turn upwards. Where those arcs intersect, I've created a new point. And I can use my straight edge to connect those points to each other. And let's talk a little bit about what kind of a shape I just built. Okay. There we go. Obviously a triangle, that's fair. But I started with length of AB. And so whatever length that length is, when I turn the first arc up, that means A to C is the same length as A to B. So this side has to be the same as AB. Likewise over here, from B to A, B is my point of turn. When I turn the second arc, and we can see that right here, then anything on that arc is the same as the length of A to B, which means this side has to match the bottom side as well. So I don't even need a protractor right now. I have created a triangle with all three sides being the same, which means triangle ABC is equilateral. And since it's equilateral, and because we know the sum is 180 degrees, I now know angle ABC, that angle is 60 degrees. So I'd write that as the measure of this angle is 60 degrees. Actually, all angles are going to be 60 degrees. So I could even put a little symbol in here to indicate that all of these angles are exactly the same. So this is how we can build angles that we know exactly how big they are, using something that seems very rudimentary, which is just a pokey part and a little piece that draws. But I've created an exact 60-degree angle using that. Okay, so we'll be able to build things like 90-degree angles, 60-degree angles, 30-degree angles. We may not be able to build every angle with this tool, but we can build so many cool things. And part of what we do here is this is definitely a tool that's accessible because, again, all it has is just a pokey part and a little piece. You may have seen some that are a little bit more like, and what do I want to say? They don't have the wheel in the middle. So I remember some from elementary school where it just had this very sharp pokey thing. I remember keep getting poked by it, and then a little piece of, and it just shoved a pencil in one side, and you would just pull it. It didn't have a wheel, so it didn't have the precision. And if it was too old, it was really loose. And the reason why you don't want one that's really loose is that it'll be really hard to keep an angle or a length locked in. Like this length is still locked in because I didn't move it. But if you have kind of an older one and you bump it and it moves, you've now lost that distance. Here's what else we can do is I'm going to take this line segment AB and just extend it because I want to show something about that feature as well. So if I just extend this line segment, okay, so I just extended it, I can take this pokey part at A, which I already knew, I know it locks in the length of AB, and now I keep the pokey part there, but I lift up the lead part and bring it over and then swing an angle over here. Okay. Okay, so now think what I've just done. I'll call this one point D in this picture. And if you take a look, A to B is a certain length. But because I locked it in, A to D is the same length. And so what I now have is in the segment from D to B, I know that A is the midpoint because you see it separates it perfectly in half. So I know that I can actually use these tools to create a segment that is perfectly cut in half. I also know that the length of DB, when I compare it to the length of AB as lengths, would be in a ratio of 2 to 1. I know that the long piece is twice as long as the short piece. So we'll be using ratios. We'll be doing midpoints, creating angles, creating sides, isosceles triangles, equilateral triangles. We're going to use these tools as we go through the chapter. So remember, compass, straight edge, doesn't need to have a ruler on it, just a straight edge. Those are the two pieces that we're going to explore. When we get into chapter 12, I'll do more examples of how to use these tools, and we'll also see how to use them using technology. So this is just an introduction to the tools and kind of some of the things we can do with them, and also hopefully a little bit of a how-to. How do I use this tool appropriately? All right, off we go.